Hello everyone, this is our lecture number 8, and in this lecture number 8 we will discuss electric dipole and electric field due to electric dipole. So first thing is, what is electric dipole? Listen. Remember, electric dipole consists of two equal and opposite charges separated by a small distance. So first thing हम देखिबा एटा गोटे arrangement. It is an arrangement of two equal and opposite charges separated by a small distance. Okay, so if you want to draw the diagram, then the diagram will be like this. This is, suppose these are the two charges, one is having charge minus q, another is having charge plus q. So two equal and opposite charges and separated by a small distance. Their center to center separation, let it be 2a. So 2a is called your dipole length. 2a is the dipole length, and in this case let midpoint of the dipole is O. Okay, so let this is your A, this is your B. So OA is equal to OB is equals to A, and here 2A is called dipole length. Yes, okay. And in other words, we can write a set of two charges of same magnitude Q. A set of two charges we can write, in other words, electric dipole is the set of two charges of same magnitude Q but of opposite sign separated by a small distance. And this is called your electric dipole. It is an arrangement of two equal and opposite charges separated by a small distance from each other. Then is our electric dipole moment. And it is denoted by a P vector. So in case of electric dipole, this is the diagram. So remember, electric dipole moment, first point, it is a vector quantity. It is a vector quantity. And second thing, it measures the strength of electric dipole. It measures strength of electric dipole. And as it measures the strength of electric dipole, so it is represented by, in third point you may write, it is represented by P vector, and P vector value, P vector is equals to magnitude of either charge into dipole length, 2a vector. Yes, so this is the vector representation of electric dipole moment. So as it is a vector quantity, so its direction is from negative charge to positive charge always. Yes, so in case of, in magnitude format, P is equals to Q into 2a, magnitude of either charge into dipole length. So from this formula, P equal to Q into 2a, we can write the unit. Unit is SI unit, charge unit is coulomb, and 2a is dipole length, it is meters. Coulomb meter is the SI unit, and its dimension will be, charge dimension is A1 T1 and dipole length that is L1. So final answer M0 L1 T1 A1. Yes, and also remember this is the dimension part. Then in point number 6, all of you remember, when the dipole length is very small, when dipole length 2a tends to 0, then dipole is called ideal electric dipole. Yes, so this is about your electric dipole and dipole moment. So dipole means it is a arrangement of two equal and opposite charges separated by a small distance, and in case of dipole moment it is the product of magnitude of either charge and the dipole length. Dipole length is the separation between two charges. So next is electric field due to dipole. So next give heading electric field due to dipole. And in this part there are three questions. One is electric field due to dipole at axial point, another one is at equatorial point, and third one is at any point of the dipole. Suppose these are the setup of electric dipole. This is the setup. And what is the axial line? Any line that joins the centers of two charges of electric dipole, that imaginary line is called axial line. This dotted line, green color dotted line, is our axial line. Any line joining the centers of two charges of electric dipole is axial line, and any point on the axial line on either side of the dipole, inside the point hai paribani, because the dipole length is very small. So any point on the axial line, that is suppose P point, is the axial point position. Let P is the axial point position which is at a distance r from the centers of the dipole. O is the center of dipole and P is the point of observation, that is axial point at a distance smaller from midpoint of the dipole. So first we have to represent what is axial line. Line joining, an imaginary line joining centers of two charges of electric dipole is called axial line, and any point on axial line on either side of the dipole is called axial point position. It may be on left side or right side. So an imaginary line that joins the centers of two charges of electric dipole is axial line, and any point on axial line on either side of dipole is called axial line position. So from the figure we are observing that 2a is the dipole length. From figure, in figure you may write, in figure OA is equals to OB is equals to small a, and O is the midpoint of dipole, and OP is equals to R, and P is the axial point position. So we have to calculate the electric field intensity, net electric field intensity at point P. Okay, net electric field intensity at point P. So how we can find? Now see, from this figure there are two charges in an electric dipole. So we know electric field intensity due to point charge formula is kq by r square, k into source charge, and we have to take the charge without sign. That means we have to take the magnitude of the charge. So first see electric field intensity at P due to plus q charge. So जो हमें इंटेंसिटी बाहर करिया सेठी हमें कौन रखा हबो, सेठी चुप ने हमें रखी देबा q नॉट, जोटा कि हम डायरेक्शन देबो. क्यू नोट है गोटे टेस्ट चार्ज बर्तमान पी पॉइंट रे क्यू नोट को प्लस क्यू चार्ज कौन कर रिपेल कर यस सो दिस इज योर इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू प्लस क्यू चार्ज अगेन क्यू नोट को आम माइनस क्यू कौन कर अट्राक्ट कर दिस इज द डायरेक्शन ऑफ ई माइनस वेक्टर इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू minus q charge. And what is the direction of dipole moment? That is from negative to positive. Negative charge to positive charge means this red color line shows that p cap. This is the direction of dipole moment p cap. Okay, so from this figure e axial vector is equals to, we can write e plus vector plus e minus vector. So from figure E net or E axial, net electric field intensity at axial point P, that is E plus vector plus E minus vector. And from figure we can write E plus means this is, and see what is the distance of point of observation when we are going to calculate the E plus vector. That means electric field intensity at P due to plus Q charge. So this distance is required. So what is its value? PB is equal to how much? O to P, this is your R, and O to B, this is A. So PB, that is equals to R minus A. So from figure again we can write here PB is equals to R minus A. And what is P to A? So P to A means O to P, this is R, and O to A, this is A. So it will be R plus A. So PA, this will be R plus A. So we can write E plus vector is KQ, K into source charge magnitude divided by the distance is PB. PB is equal to R minus A. So this will be R minus A whole square. And E plus vector, vector sign is written means we have to write the direction. So again see E plus vector is along the direction of dipole moment, that is along P cap. So we can write P cap plus again E minus is K into source charge magnitude minus Q charge magnitude is Q divided by R plus A whole square, KQAR square, into direction. So what is the direction of E minus vector? It is opposite to the direction of dipole moment. So that is minus P cap vector. So minus P cap, only minus P cap. So we can write KQ take common. So in bracket you can write the both expression, and this is your P cap. So K, Q and P cap आम कमन ना आ रहा के 1 by P cap कमन जाइए. So 1 by R minus A whole square minus 1 by R plus A whole square. So it will be K into Q, LCM is R minus A whole square into R plus A whole square. So it will be R plus A whole square minus R minus A whole square. And P cap, direction is P cap. So in numerator we can see, numerator part we can observe A plus B whole square minus A minus B whole square, that is 4AB. So this will be 4RA divided by, it can be written R minus A into R plus A whole square, again P cap. So in numerator part we can write K into small k, that is Coulomb's constant, Q into 2A into 2R. 4RA can be written 2A into 2R divided by R plus A into R minus A, that is R square minus A square whole square into P cap. Again this Q into 2A, that is your dipole moment. So 2KPR divided by R square minus A square whole square into P cap. This is our E axial vector. This is E axial vector. 2 kpr by R square minus A square whole square. Okay, in general this is the expression, you can write like this. And remember jodi amar rahila eti kono, this is our electric dipole, this is our suppose electric dipole, a small electric dipole, yes. And in this situation this is the axial line, this is your axial line, and let the point of observation P is at this point, and this is the midpoint of dipole. From midpoint of dipole to point of observation, this distance is R. So in this case, from point of observation P, the dipole behaves as a short dipole. A dipole is very small. dipole behaves as short dipole. So in this case, in case of short dipole, we can observe R is much greater than A. So as A is very small in comparison to R, which implies A square tends to 0 or nearly equals to 0. So in this case, for short dipole, E axial will be, so for short dipole, E axial vector will be, instead of A square, we can put 0. So 2 kpr divided by R square minus 0 whole square into p cap. That is 2 kpr divided by R fourth p cap. So it will be 2 kp by R cube into p cap. Instead of this k, we can write 1 by 4 pi epsilon naught. So clearly from this expression we came to know E axial is conclusion. What are the two conclusions? Conclusion is, first point, E axial vector for dipole, that is your answer 2 kpr by R square minus A square whole square, 2 kpr divided by R square minus A square whole square into p cap, or you may write 1 by 4 pi epsilon naught, that is k, then 2 pr by R square minus A square whole square into p cap. Second is, this is for dipole. For dipole, if dipole is very small, for short dipole, E axial is 2 kp by R cube into p cap. Third thing, clearly from this expression we can say E axial is proportional to 1 by R cube. This is one expression. Another thing, net intensity due to axial position is along the direction of dipole moment. So E net or E axial vector, E axial is along the direction of dipole moment. Dipole moment, which is denoted by the letter P. That means E axial vector is parallel to P vector. So what is the angle between dipole moment and axial net intensity due to axial point? Which implies theta is equals to 0 degree in this case. So this is about your electric field intensity due to dipole on axial line. So first is our at axial point, case 1. Case 1 is at axial point. So this is the expression. So what is axial line and how can we draw the diagram? Now see. Now you can take the screenshot. So A and B both is your, it is a setup which is called your electric dipole, AB. Then we have to find the electric field intensity due to dipole at broadside end position. What is the other name of axial line? Axial point position or axial line position you can write at axial line position, or it is called end on position of dipole. It is called end on position due to dipole. Okay. Next is electric field intensity due to dipole at broadside end position. You can take the screenshot like this. This is for short dipole. This is a special case for short dipole where R is much greater than A. Yes, I hope it is clear. Next, come to electric field intensity due to dipole at broadside end position. Or it is called equatorial line position. So now see what is broadside end position or equatorial line position. Now remember, if this is our dipole, any line which is perpendicular to axial line but that passes through the midpoint of dipole. This is suppose any line which is perpendicular to axial line but passes through midpoint of dipole, that is called your broadside or equatorial line. And any point on the equatorial line is called equatorial line position. Let P is that point. This is our equatorial line position. P is that point. So in this part we can write here any line that passes any line which is perpendicular to axial line and passes through midpoint of dipole is called equatorial line. And any point on it means on equatorial line is called equatorial line position. It's called equatorial line position. Okay, this is the meaning of equatorial line position. So now see how to calculate the intensity at this point. So from this figure, same thing, this is O to A. O to A is your A. Similarly, O to B, this length is A. O is the midpoint of dipole. And the point at which we are going to calculate intensity, we have to put Q naught charge in order to find the direction. A minus Q naught को कौन करिवो को माइनस Q naught को अट्रैक्ट करिवो. सो ये डिस्टेंस टा निहाती दरकार हमरो. ये डिस्टेंस देखो, ये डिस्टेंस दरकार in order to find the intensity. Okay, and this PB distance is also required. Okay, now see a Q naught को minus Q कौन कला अट्रैक्ट कला. So हम कहि परिबा this is the direction of E minus vector. Here we can say this is E minus vector. And what is the direction of E plus vector? Plus Q charge Q naught को हम repel कला. This is the direction of E plus vector. बस. अच्छा आ गोटे कथा देखो, ये ट्रायंगल रे जो भीतर जो ट्रायंगल देखा है, लेट दिस एंगल इज थीटा एंड दिस एंगल आल्सो थीटा. देखो जो दुटा ट्रायंगल हम देखिए वर्तमान, ये दुटा ट्रायंगल मु देखो शेडिंग करी. इन दिस टू ट्रायंगल, these two triangles are similar. These two triangles are similar. केमती? अच्छा, what is the distance of this point of observation P from midpoint of dipole? Let this R. Let this is R. And this side is common. दुटा ट्रायंगल रे these two angles are equal. बुझला? अच्छा, this side भी equal. एटा A अछि देखो, ये equal. So these are similar. ये डिस्टेंस टा केते हो? PA equal to PB, that will be R square plus A square root over. This distance will be R square plus A square root over. In other part also this distance will be R square plus A square root over. Yes, okay. So बर्तमान में देखिए मैग्नीट्यूड बाहर करबा कार E plus vector and E minus vector magnitude. What will be the magnitude of E plus vector and E minus vector? अच्छा, see this. So magnitude of E plus vector केते हो? K into source charge magnitude divided by distance square. So R square plus A square root over. This is your distance, that square. So answer is KQ by R square plus A square. Next thing, E minus vector magnitude. This will be KQ divided by R square plus A square root over. This is the distance whole square. It is minus Q पे को होची minus Q रो magnitude नहीं होला. So this is KQ divided by R square plus A square. So from this we came to know E plus is equals to E minus. So magnitude wise लिखली. E plus vector magnitude is equals to E minus vector magnitude. Okay? Yes. अच्छा, बर्तमान जब मैं कंपोनेंट रे स्प्लिट करबा काकू E plus vector को केतरा कंपोनेंट बाहर देखो. These are the two components. This is one component, this will be another component. So कोटा cos component कोटा sin component अब देखिबा. देख गोटे जेड फॉर्मेट कॉन्सेप्ट मुझे तुमको कही जो मैंने किसी जापार देख यहाँ जेड फॉर्मेट कॉन्सेप्ट so this angle is theta means this is also theta that means these two are parallel lines and this is the intersect so angle theta आसीगला आमर जाना पड़ला this angle is theta yes another case देखो ये आ गोटे जिनस these two lines are parallel এটা intersect कला ये देखो this is theta means this is also theta yes so आम से मार्क करवा so this angle is also theta so बर्तमान angle attaching component cos component this is e plus cos theta this will be e plus sin theta okay next thing similarly e minus vector भी दीटा component आसीबो गोटे e minus cos theta e plus cos theta कौन हम this is one component and तलू रहा हमरो another component yes केमती गोटा देखा देख so angle attaching component cos component so along negative y axis जोटा रहा negative x axis so this is your e minus cos theta and तलू रहा आमर e minus sin theta diagram clear now also देखो along y direction बड़ा कॉन्सेप्ट ये आसीबो जब y direction को भलसे ऑब्जर्व करबा इन y direction हम रहिला के e minus sin theta तलू रहिला और आमर e plus sin theta ऊपर रहिला along positive y axis e plus sin theta along negative y axis e minus sin theta yes so both are equal in magnitude because e plus and e minus both ro magnitude कोन अछि सेम अछि so बर्तमान कोन हो e plus sin theta is equals to e minus sin theta so net intensity along y direction केते आसिला 0 equal in magnitude opposite in direction so हम लिखिबा e net e y along y direction e y net is equals to 0 yes as e plus sin theta is equals to or e plus sin theta is equals to e minus sin theta due to this e net along y direction is 0 so net intensity will be 8 have our net intensity kuda this will be our net intensity yes acha I figure हमरो p cap रो डायरेक्शन कोडे नेगेटिव टू पॉजिटिव so this negative to positive तळे मु जो लाइन टा करछु ब्लू कलर रे देखो नेगेटिव टू पॉजिटिव this is the direction of p cap so this is your p cap yes okay ए लाइन टा कोनटे तळु गनिबा this is p cap yes so net intensity केता बताले e plus cos theta plus e minus cos theta एटा को डायरेक्शन अछि along x axis देखो अछि नेगेटिव x axis तो माने ये net intensity कोड हला ताले this is the direction of net intensity this is the direction of net intensity e net और एटा हम कहि परिबा e equatorial एटा कहा डायरेक्शन आसले opposite to direction of dipole moment so हम लिख परिबा minus q so thus हम एटी यूज करिबा e vector equatorial केते आसला 2 e और एमती हम लिखिबा स्टार्टिंग रो e plus cos theta plus e minus sin theta then minus p cap and e plus cos theta e minus sin theta both are magnitude equal so we can write it as 2 into e plus cos theta minus p cap 2 e plus ro magnitude kete e plus magnitude k q by r square plus s square so we can write k into q by r square plus s square this is your e plus and what is the value of cos theta so in this triangle जे कौन सी triangle देखिए blue color की red color cos theta केते हो a by r square plus s square root over so here we can write a divided by r square plus s square root over then रहला minus p cap okay so q into 2a so in numerator part numerator हम जो देखिबा q into 2a that is your p ताको अरेंज करिबा लिखिबा so k into q into 2a divided by in denominator it will be r square plus s square power it is power 1 and it is 1 by 2 so this will be 3 by 2 1 plus 1 by 2 3 by 2 then this is minus p cap and q into 2a this is your dipole moment p q into 2a is dipole moment p so it will be kp divided by r square plus s square power 3 by 2 that small k coulomb's constant then minus p cap and instead of k you may write 1 by 4 pi epsilon naught so this is the answer of e vector equatorial net intensity so jana payla eti kono this is opposite to the direction of dipole moment yes again आम कंडीशन अप्लाई करिया फॉर शॉर्ट डाइपोल so for short dipole condition is r is much greater than a which implies a square tends to 0 a square tends to 0 means thus e equatorial e q vector this will be kp by r square plus 0 power 3 by 2 into minus p cap. So the answer will be kp by r cube r square to the power 3 by 2 that is r cube into minus p cap. This is your e vector equatorial. E vector equatorial. So clearly we can say thus E equatorial is proportional to 1 by r cube also and direction is opposite to dipole moment. E equatorial direction is opposite to dipole moment. Yes, so what is the value of theta opposite to dipole moment means we can write E equatorial vector is parallel to minus P vector, okay, anti-parallel. So theta is equals to 180 degree in between them. जो पटे आम रहा डाइपोल मोमेंट तार अपोजिट डायरेक्शन आम किए आसला नेट इंटेंसिटी. सो स्टार्टिंग रू देखा एनी लाइन व्हिच इज परपेंडिकुलर टू एक्सियल लाइन दैट passes through the mid point of dipole is called equatorial line and any point on it is called equatorial line position or broadside on position. Yes, so this is the diagram and you may take the screenshot and this is our final expression and for short dipole it will be kp by rq. So आम जो देखा बर्तमान नोट पॉइंट गोटे जिन देखा E axial magnitude is for short dipole note point. For short dipole we can say this is in case of short dipole only. E axial is equals to 2 kp by rq and instead of this kp by rq we can write 2 into equatorial. Kp by rq is equatorial, that means E axial divided by E equatorial is equals to 2 by 1 or 2:1. The ratio is 2:1. Okay, so dita case हमर finished हो गला ठीक से. So next is our electric field intensity due to dipole at any point P. देखिए electric field due to dipole at any point P. So any point रे dipole रो any point रे intensity केमती बाहर just see. एटा भी बहुत छोटो question रे आसीबो एटा. So this is suppose our dipole. Yes, and P is any point which is at a distance r from the midpoint of dipole. Yes, अच्छा एठी dipole moment direction, dipole moment negative to positive, so this line represents P vector and let P vector and R vector position vector of point P with respect to midpoint of dipole, that is R vector. Let the angle between them is theta. So theta is the angle between R vector and P vector, remember this thing. And A point रे हमर अछि minus q, B point रे अछि हमर plus q charge of dipole. बर्तमान P vector हम दुईटा कंपोनेंट रे स्प्लिट करि परिबा. यस, तर दुईटा कंपोनेंट आसीबो. गोटे कंपोनेंट एटा आसीबो देखो, दिस इज वन कंपोनेंट and this will be another component. गोटे sin component गोटे cos component, both are perpendicular. So angle attaching component cos component, so this will be P cos theta. Let it be P1. Yes, and this is suppose P2, that is your P sin theta, other component will be P sin theta. बर्तमान देखो आम बर्तमान कन्क्लूजन कौन देखले फास्ट डायग्राम को देखो. फास्ट डायग्राम रे हमर डाइपोल मोमेंट के थिला P, एटा थिला डाइपोल मोमेंट. सो डाइपोल मोमेंट डायरेक्शन रे जदि हमर पॉइंट P रही गला, पॉइंट ऑफ ऑब्जर्वेशन बुझिला, सेटा को हम कोन कहबा एक्सियल लाइन. क्लियर. सेकंड पिक्चर रे देखो एटा ला डाइपोल मोमेंट, ओके, किंतु पॉइंट पी कौन अच्छी परपेंडिकुलर लाइन जोड़ा है तुम डाइपोल मोमेंट लाइन को से जब पॉइंट पी रहीगला से तुम कौन इक्वेटोरियल लाइन पोजिशन बुझीगला। सो ये दुटा केस को देख ये डाइपोल मोमेंट के पी सो आंसर बाहर के पी बाय आर क्यू ई इक्वेटोरियल ई एक्सएल बाहर के 2 के पी बाय आर क्यू एटी है मोर पॉइंट ऑफ ऑब्जर्वेशन पी ये दुटा सेम सेम होगा पॉइंट ऑफ ऑब्जर्वेशन पी नहीं जाइए डाइपोल मोमेंट भी पी नहीं जाइए ओके छाड़ तुम अदर पॉइंट जहाँ भी नहीं पार किसी असुविधा ना। सो फॉर पी कॉस थीटा डाइपोल मोमेंट देख पी कॉस थीटा डाइपोल मोमेंट तार डायरेक्शन आमर किए रहा से डायरेक्शन में आमर पॉइंट ऑफ ऑब्जर्वेशन रहा तो पीटा कौन हम पॉइंट ऑफ ऑब्जर्वेशन बिहेव्स एज एक्सियल पॉइंट को डाइपोल मोमेंट फॉर पी कॉस थीटा डाइपोल मोमेंट पी बिहेव्स एज पॉइंट ऑफ ऑब्जर्वेशन पी बिहेव्स एज एक्सियल लाइन मन रहा। सो एक्सियल लाइन है माने तार इंटेंसिटी को डायरेक्शन हो इंटेंसिटी अलोंग द डायरेक्शन ऑफ डाइपोल मोमेंट एटा अलोंग द डायरेक्शन ऑफ डाइपोल मोमेंट दैट इज योर E1 वेक्टर आम दबा आम दिस इज सपोज योर E1 वेक्टर यस। अच्छा बर्तमान देख फॉर पी साइन थीटा डाइपोल मोमेंट पी साइन थीटा डाइपोल मोमेंट परपेंडिकुलर लाइन सो सेठी जदि पॉइंट ऑफ ऑब्जर्वेशन रहा सो पॉइंट ऑफ ऑब्जर्वेशन पी बिहेव्स एज इक्वेटोरियल लाइन पोजिशन फॉर डाइपोल मोमेंट पी साइन थीटा तापाई जो इंटेंसिटी बाहर केमती बाहर अपोजिट टू डाइपोल मोमेंट ऑब्वियसली अपोजिट टू डाइपोल मोमेंट डाइपोल मोमेंट किए पी साइन थीटा तार अपोजिट देख रहा है पी साइन थीटा एंगल थीटा 180 है एंटी पैरेलल 180 डिग्री। सो दिस इज योर E माइनस वेक्टर और ये सॉरी E माइनस कौन E2 वेक्टर कहीपर फॉर डाइपोल मोमेंट P2 क्लियर। सो बर्तमान आम देखा कौन आंसर लिखा सेमती फॉर डाइपोल मोमेंट P1 इक्वल टू P cos थीटा पॉइंट ऑफ ऑब्जर्वेशन P बिहेव्स एज एक्सियल लाइन पोजिशन ओके। सो से टाइम तुम E1 के बाहर एक्सियल लाइन पोजिशन बाहर 2 इंटू 2K डाइपोल मोमेंट बाय आर क्यू। सो ये लिखा आम 2K पी न लिखिए आम लिखा P cos थीटा कारण डाइपोल मोमेंट है P cos थीटा डिवाइड बाय ये पॉइंट ऑफ ऑब्जर्वेशन मिड पॉइंट टू डिस्टेंस के आर सो हियर आर क्यू। सो दिस इज द वैल्यू ऑफ E1 यस 2K P cos थीटा बाय आर क्यू और 2K P1 बाय आर क्यू। देन सेम लाइन आम लिखा फॉर डाइपोल मोमेंट P2 इक्वल्स टू P sin थीटा पॉइंट ऑफ ऑब्जर्वेशन P बिहेव्स एज इक्वेटोरियल लाइन पोजिशन which implies E2 will be कितने थे आंसर K P2 divided by RQ. So it will be P2 value के P sin theta. So K P sin theta by RQ. So this is the answer of E2. So बर्तमान देखो तार वेक्टर एडिशन नवा केमती देखो ये E1 and E2 both are perpendicular केमती जानूचे यहाँ along रहा यहाँ कौन रहा एंटी पैरेलल बर्तमान P1 और P2 कौन थे परपेंडिकुलर थे ना P1 and P2 90 डिग्री। सिमिलरली P1 डायरेक्शन रहा तुम E1 और P2 अपोजिट डायरेक्शन रहा किए E2। सो दिस विल बी ऑल्सो एंगल बिटवीन द E1 and E2 दैट इज ऑल्सो 90 डिग्री ओके। एंगल बिटवीन टू वेक्टर्स 90 डिग्री अच्छी व्हेन टू वेक्टर्स आर परपेंडिकुलर टू इच अदर रिजल्टेंट केते हम E1 स्क्वायर प्लस E2 स्क्वायर रूट ओवर। अच्छा रिजल्टेंट पाइबा को कौन करिया पड़े गोटे पैरेललोग्राम ड्रा करिया एंड देन डायगोनल स्टार्टिंग फ्रॉम देयर कॉमन टेल पॉइंट gives the direction of resultant intensity E net. So ये आम लिखा E net vector okay and direction पाइबा let E net makes an angle phi with respect to E1 direction पाइबा tan phi 1 रे सॉरी tan phi बाहर करिया tan phi केते हम ये डायरेक्शन आगे बाहर करिया tan phi इज इक्वल्स टू देखो ये गोटे राइट एंगल ट्रायंगल देखा ये राइट एंगल ट्रायंगल tan phi केते हम यहाँ E2 मीन्स यहाँ भी E2 and this is your E1. So perpendicular by base कला माने E2 by E1 E2 by E1. So tan phi is equals to E2 value Kp sin theta divided by RQ whole divided by 2 Kp cos theta डिवाइडेड बाय आर क्यू कैंसल है 2 केपी कैंसल हो गला देख आर रहा के साइन थीटा बाय 2 कॉस थीटा सो इट विल बी 1/2 tan थीटा एटा कहार वैल्यू tan फाइ रो वैल्यू सो फाइ विल बी tan इनवर्स हाफ tan थीटा डायरेक्शन आम लास्ट लिखा एटा को सो बर्तमान बाहर करें मैग्नीट्यूड सो ई नेट विल बी सो आज E1 vector is perpendicular to E2 vector so thus E net vector is equals to or E net vector magnitude केते होबो E1 square plus E2 square root over E1 value 2 kp cos theta by rq whole square so 2 kp cos theta by rq whole square plus kp sin theta divided by rq whole square root over yes so this will be equal to 4 k square p square cos square theta divided by r to the power 6 plus k square p square sin square theta divided by r to the power 6 root over yes again हमें कॉमन केते नहीं परिबा k square p square by r to the power 6 आ ब्रैकेट भीतर रहला हमर 4 cos square theta plus sin square theta रो होल रूट ओवर yes next thing k square p square by r to the power 6 root over is kp by rq आ रहला तमरो जो ब्रैकेट सॉरी रूट ओवर भीतर रहला केते 4 square theta 4 cos square theta plus sin square theta so it can be written 4 cos square theta को लिखिबा 3 cos square theta plus cos square theta plus sin square theta yes बस so cos square theta plus sin square theta हमारा आसला 1 so the final answer is kp divided by rq 3 cos square theta plus 1 root over this is the value of E net intensity due to dipole at any point kp by rq 3 cos square theta plus 1 and the direction part हमें कर सारी ऑलरेडी tan phi result हमें ऑलरेडी देखिले एठी for direction tan phi is equals to we got tan phi is equals to half tan theta which implies phi is equals to tan inverse half tan theta yes so always remember भलो जिनस रेडी मन रखिबा कोन थीटा एंड फाइ का भीतर एंगल देखो थीटा इज द एंगल बिटवीन r वेक्टर हम कहि परिबा r वेक्टर एंड p वेक्टर yes and phi is the angle between E net vector and E1 vector hello so jodi one question asibo eti what is the value of theta plus phi from the figure so jodi hame dekhiya theta what is theta angle between r vector and p vector dipole moment and what is phi angle between E net vector and E1 vector okay जो थीटा प्लस फाइव पचारिबा केमती हम जदि एठी मोडे पैरेलल ग्राम और सॉरी पैरेलल लाइन ड्रा कली विथ रिस्पेक्ट टू एक्स एक्सिस देखो तो कौन देखा जाउछ एठी दिस टू लाइन्स आर पैरेलल देखा गला एटा इंटरसेक्ट हैला सो दिस इज थीटा मींस दिस इज आल्सो थीटा यस सो जदि हम से अनुसार देखिबा ताले दिस इज आल्सो थीटा लास्ट टाइम देखले कोन दिस एंगल इज थीटा so what is the value of theta plus phi theta plus phi is equals to 90 degree eta numerically use hobo ei concept theta plus phi from the figure theta plus phi is 90 degree and what is theta and what is phi clear so this is about your electric field due to dipole at any point you can take the screenshot now on the for dipole moment p1 point of observation gives us axial position and for dipole moment p2 point of observation gives us equatorial line position से अनुसार हमें आंसर लिखिबा सो एटा थियोरेटिकल पार्ट तो एक्सप्रेशन सब लिखि दियो स्क्रीनशॉट नहीं जाओ फाइनल आंसर kp by rq 3 cos square theta plus 1 root over and tan phi is equal to tan theta by 2 so what is the value of theta plus phi is 90 degree okay so what is electric dipole and electric field due to electric dipole okay this is already completed so in lecture number 8 we have completed about your electric dipole and its and the field due to electric dipole. I mean lecture number 9 रे हमरो dipole and axial line, equatorial line and any position ए related जहाँ भी अच्छी numerical सब solve करिया. Okay, so stay tuned for next update and like, share and subscribe my channel. Thank you.